All right, thanks, Jason. And I want to just say thanks again to Centair for sponsoring us tonight. I really appreciate that. So as Jason mentioned, we're going to be talking tonight about top performance with Angular and .NET Core applications. And my name is Jonathan Tower. I go by Jay for short, as Jason mentioned. Feel free to call me that if we get the chance to talk on this call or in person at some point, hopefully in the future. And a little bit about me before we get started. I'm a partner, founding partner and principal consultant at Trailhead Technology Partners. Centair is the quality consulting company. We'll say that Trailhead is the next best right after that, since they're our sponsor tonight. So we do some very similar work to Centair. We do custom application development, help our customers build custom software using web and mobile and back-end technologies, IoT, cloud, integrations, all of that kind of stuff. Do a lot of applications using Angular and .NET Core or .NET 5 as it's known now. So what we're talking about today comes from a lot of our experience with building these applications and helping clients to get their applications to be even more performant. I'm also a Microsoft MVP in .NET, and I believe that has been almost 7 years. So I'm coming up on my 7-year anniversary for that. And also a Telerik, or now Progress, developer expert and organizer of a conference here in my hometown, which is called Beer City Code. And would love to have all of you come visit us at some point in the future when we're able to have that event again. It's always in the summer, so we just recently announced that we'd be delaying that until next summer, just to be safe. So hopefully next summer, you all can drive around the lake to Grand Rapids and enjoy some beer and some code and some in-person time with non-virus carrying people. If you do want to reach out to me at all, you can reach out at any of these places you see on this slide online, as well as some others. And I do have a link here at the bottom, which I'll show again. This is a link to a GitHub repo where I've got all these slides from tonight's presentation, if you want to check those out again later. And then I think Jason mentioned this whole presentation will go to YouTube channel for the user group as well. All right, so I always like to talk about what we're going to cover, just to kind of set expectations. So after this introduction, I'm going to pretty much jump right into 12 specific performance tips from Angular applications, from our experience over the years building performant web applications. And then after that, I'll switch to the 10 .NET Core or .NET 5 performance tips. I do want to encourage folks to ask questions at any time. It is a little bit hard to keep my eye on what I'm talking about, what I'm about to talk about, and the chat. So if you do have a question, you want to post it in the chat, maybe Jason can be willing to come off of mute and let me know if there's a good question in there that we should answer.
Yep.
Cool, thanks, Jason. A couple of things, just FYI, a couple of things we won't cover. We're not going to kind of do like an introduction to Angular or an introduction to .NET Core or .NET 5. And the reason for that is not because those aren't interesting or valuable, but because those are very deep topics that we could spend the whole time on each of those. And I want to get into something a little more specific. So I'm going to just assume, hopefully, that you at least are familiar with these. You know a little bit about building SPA applications, maybe in React, maybe in Angular. A lot of these things will apply to both. And that maybe you know at least the basics about .NET Core and .NET 5. If you feel like that does not describe you and you want to kind of get caught up, I'd recommend going to these links here as a good starting place. So angular.io/docs is a great place to get caught up. And then for .NET, if you go to .NET.microsoft.com/learn, there's tons and tons of resources there to get you caught up on what's going on in .NET. So hopefully that's helpful. And for anyone that's feeling a little behind on those, those are some good starting points for you. One more quick thing before we actually get into the real juice. This is something I like to do at all my talks, and that is to basically encourage all of us to give back together. So I do all of these talks, obviously not as a way to make the big bucks or anything like that, or even to get free pizza, because that's not happening anymore these days when it's online. But I do it as a way to give back, and that's because over the years there's been a lot of people who've fed into my life and my career, either in kind of a one-to-many scenario like this, or a one-to-one scenario, maybe at a job I've been at or something like that. And I just think doing this is kind of my way of paying that forward. And yet, all of us are quite lucky to be in a industry where even during this pandemic, most of us have been gainfully employed. In fact, there still seems to be more demand for software people than there are software people. So if you feel like you get anything valuable out of this talk and you want to kind of pay that forward, I would love it if you'd go to this bit.ly link, which is bit.ly/wi-water. And if you donate there, just to put my money where my mouth is, if everybody on this call together tonight, if we hit 200 bucks, I will match that 200 bucks as well. So if you also hate the talk and find it to be a waste of your time and you want to punish me, that would probably be a good way to do that too. All right, so let's jump in now. By the way, that's link is up here at the top, bit.ly/wi-water. And if it works correctly, this little progress bar should update us throughout the talk if people are going there and seeing how close we're getting to that goal. Okay, so let's jump in with the Angular performance tips. The first one is, I think, a really cool one. If you are already familiar with SPA applications, you know that they work. You can build a SPA application inside of an ASP.NET application or hosted by an ASP.NET Core application, but you certainly don't have to. And actually, for our clients, we often recommend that there's some architectural advantages to separating the front-end application from the middle tier or like API application. And so we often start with that as the architecture that we recommend for our clients. When you do that, if you think about what you end up with when you compile or build your Angular or React application, is you actually end up with essentially just a bunch of static files, HTML, CSS, JavaScript, bundles. And really nothing delivers faster to a user over the web than static files. And it's kind of overkill, actually, to have any kind of server-side processing language like an ASP.NET, like IIS, anything like that. Really is kind of overkill if you're just trying to deliver some static files. What really is good at that is a CDN in front of blob storage or like just a simple cloud-based file storage. So what we often do for our applications is we'll go to Azure, which is our preferred cloud. We'll set up a blob storage, which is essentially like a file storage. You just copy all your files up there. We'll usually set up a CI and CD pipeline to do that automatically as part of our automated processes when we check code into our repositories. Copies automatically out there to the blob storage. That blob storage, you then set it up to be fronted by a CDN. In about 5 minutes, you can set all of that up, and you've got a very simple front-end web host. You can do custom domains, you can do SSL. Even the CDNs allow you to do redirect and rewrite rules. So for example, if you want to set up your front-end web application so that all the HTTP traffic gets redirected to HTTPS, you can set up a very easy rule that does that. On Angular and other SPA kind of applications, you often want to have a rewrite rule on your web server that basically says any route beneath the root of the application actually gets rewritten to go right to the index.html page. And that way, if somebody reloads the application when it's on a sub navigation, on the client-side navigation route, it'll actually still load the index page and then allow the Angular app to route to that route within itself. So I've done this now many times, including a few times where we've migrated from a cloud-based host to a CDN backed by blob storage. And what I often find is that we go from maybe like $40 to $400 a month, depending on how you've got all of that hosting set up, to literally pennies a month. So as an example, I was paying for my personal website about $40 a month to host that. And I had it so that I could run ASP.NET Core on the back end and do all kinds of server-side custom stuff. And what I realized is that my personal website doesn't update that much. It would be much easier to just use static files. And so I moved it over to the CDN. Instead of $40 a month now, I literally spend between 4 to 6 cents every month on that. So very inexpensive to use. And then you get all the advantages of using a CDN as well, which, for example, means that you could have a CDN that runs in multiple locations around the world. So maybe you've got clients in Asia or Europe, as well as in the US, and you want it to run really fast for them. Well, you could set up a CDN that fronts your application in Europe, Asia, and the US. And just by updating one blob storage location, all of those CDNs will get updated, and all of your users around the world will get fast access to those web files for your front-end web application. So that's my first tip. Second one is, when you're using Angular, is to use the on-push change detection strategy. So if you're not familiar with Angular, one of the things that was introduced in Angular 2 and on was the couple different kinds of change detection strategy. And what that basically means is how Angular knows when to update different parts of the page based on the underlying data that you've bound to that page and when it's changed. And the default strategy is called default, which I don't know if that's the best name. It is technically accurate, but it's not very descriptive about how it works. I like to think of it as sort of the overactive change detection strategy, or you could think of it as like the demoware change detection strategy. It's the one that Angular put in there because they wanted you to be able to download Angular and try your very first app in Angular and have that just work without having to really understand it well or get really familiar with the complexity, some of the complexities that can come up with change detection in your application. So why would you want to change it from that if that's the easiest one? Simple performance, which is all about what we're talking about tonight. When you change from default to on-push, the Angular application is going to have to check a lot less often for change detection, but you are going to have to become more of an expert on how to do change detection. So just as some kind of general rules, any DOM events, any clicks, any scrolls, anything like that that happens in the browser is still going to flow through to your components. And then any property on your components that you mark with the input tag is going to still cause change detection to rerun and your component to re-render with the on-push change detection strategy. There's a few exceptions to that, but you can think of those as kind of the general rules. If you don't do that, then what happens instead is Angular just does a lot more change detection, which of course means that your application is a lot more busy just doing change detection rather than your business logic, which means that the more complicated application you get, the worse performance you're going to see. So this is the first thing we often recommend to clients if they haven't changed from the default strategy to change to that, and then go through the application and make the changes and fixes, adding the input attribute throughout to mark all the properties that actually should cause change detection to run and re-render components. All right, so another thing to think about is when you're binding to things in Angular, that you want to generally bind to properties, not to functions in your components. So here I have an example where there's a class being bound on this div to a function, and then also some content inside the div, some text content is being bound to another function. So what's going to happen in this case is that every time Angular runs the check to see if anything has changed, it's going to have to rerun these functions, because there's really no way for Angular to know whether these functions are deterministic or not, whether they will return a different result if it reruns them. There's no way to know that without actually rerunning them and seeing what result they actually return and seeing if that is different from what they returned last time. And so when you use functions like this to bind things to, you'll find that these functions will run a whole ton, and that can cause your application, especially if it's a bigger one, to perform really poorly, as all of this code needs to rerun all of the time. If you just change those to properties, where you and your backend change the property whenever you want something to change on the front end, and then just bind that property inside of your view, then you'll find that you'll get much better performance. And the reason for that is that Angular can actually tell anytime a property changes on one of your components, and it can automatically cause, depending on what strategy you're using, of course, it can automatically cause your component to re-render based off of that property change, and you get a lot less code executing unnecessarily. So that's the next thing I would recommend. Another one to think about is a lot of times when we meet a client who's created their own SPA application or single page application with Angular, a lot of times they'll have started out by creating that whole application as just one massive bundle, or maybe two massive bundles. Maybe they put all of the third-party code in one bundle and all of their code in another bundle. That's not an uncommon way to do a small application, but maybe that application has grown over time and those bundles have started to get a little ridiculous. Maybe you're downloading 2 megabytes or 10 megabytes worth of JavaScript when you first hit the application. That, of course, can, for a first-time user, can cause a really slow initial app load time because they have to download that huge chunk of JavaScript file just for the application to even sort of boot up and get started. One of the things you can do is kind of split your application up into different modules. So say, for example, you want your login screen and then maybe the dashboard page that you hit right after you log in to be part of one module. And then maybe all of the other stuff goes into a few other modules, based on where people go and that tend to go in the application most frequently. And if you did that, you could set up your routing like this, where you have your first component, and that's just defined as this component that you've created. But then you could create a second component and set it up to load, lazy load on demand, by just doing this statement right here. And what that's going to do is it's not going to include the second module in your main bundle. It's going to actually create a separate bundle for it. And then when somebody routes to the second dash component route on your application, it will automatically go load that module. And if the user hasn't downloaded it yet, it will download it. Now, another thing you can think about is once you make this change to kind of load on demand, you can think about maybe running some code in the background so that once the user has logged in and is on the dashboard, maybe in the background, you could be downloading some of the other modules. And I'll talk a little bit more about that on one of my future tips here. The next one that we see, especially with data applications with a lot of data in them, is people who kind of haven't thought at all about things like infinite scroll or virtual scroll or lazy loading of UI components. And so if you're, for example, doing this list over here, which has about 100,000 items in it, if you're actually creating 100,000 DOM elements, all of which are bound to a component in an array in JavaScript, that's a lot of things for Angular to have to check for updates on all the time and to re-render. Of course, we're only looking at 4 of them here at a time. The other almost 100,000 of them, minus 4, are scrolled out of view at any given time. And so it's kind of silly to be doing change detection on all of those 100,000 when you really can only see 4. Of course, it's also difficult to implement, but there's a lot of third-party things you can use, such as the material design components for Angular, which you can check out at material.angular.io, has this great scrolling component. And then also a lot of their built-in components have a lazy loading of elements built right into them. And so as you scroll, what happens is it actually creates DOM elements just in time as you're scrolling and destroys other ones. And so it's only really tracking a small number at any given time. And you're going to see a lot better performance in your application when it's not tracking 100,000 elements here. And another example that's more something you might do yourself is if you think about maybe like a grid that has a link on each row, and clicking on that link opens like a pop-up in your application. And if you tell the application to go ahead and create a pop-up ahead of time for each of those elements in that grid, let's say there's 1,000 elements in the grid typically, that's going to be 1,000 DOM elements and the whole tree beneath them for every single pop-up that could be opened by the user, times 1,000. And that's, again, a lot of elements for Angular to track, especially when you consider that probably most of those the user is never going to look at least not this time that they're on the page. So it actually makes a lot more sense to set your code up so that that pop-up gets rendered into the DOM only when the user clicks on the link. That way, there's a lot less stuff for Angular to track for rendering. All right, this one is great. For those that are using RxJS in their Angular application, RxJS has some cool operators that you can use. And we often recommend these for if you're doing anything with browser events. So the most common one that can cause problems for performance is the scroll event. If you've not noticed this, if you actually do a scroll on certain browsers, I think especially true in Safari on the Mac, but when you do a scroll, just one scroll gesture on your trackpad or on your mouse scroll wheel can create hundreds of scroll events just instantaneously for your code to handle. So if you're just listening for the scroll event and then running some code to, like, I don't know, move a component back into view or something like that to make it like a floating component, well, you're going to be checking that hundreds of times a second whenever the user scrolls. And obviously, there's no need to have that kind of frame rate for keeping something in view. But also, that's a lot of recalculating, that's a lot of recalculating of coordinates that may not even get used because they're just getting replaced by another scroll event that happens a millisecond later. So what you can do is you can, for example, use the debounce time operator in RxJS, which will basically, you can tell it that you want to know about the scroll event, but you only want to know about it once every 250 milliseconds. And if more scroll events happen within 250 milliseconds, to just tell you about the first one that happened. And that's a really great way to make sure that your application isn't running a bunch of logic over and over again, but is only really doing it as much as you need to get the performance that you're looking for, and leave those processor cycles for other things in your application. All right, another one that's really useful that we sometimes see, especially in older Angular applications. I can't remember what version of Angular it was, but there was a somewhat recent version that actually made pipes the pure by default. But before that version, I want to say it might have been version 7, but anyway, whichever version it was, before that, they were not pure by default. And what does it mean to be a pure pipe? Well, pipes are kind of like a filter or like a function that you can run your bindings through in Angular. And to be a pure pipe basically means to be deterministic, which means, in turn, that given the same inputs, the pipe will always return the same outputs. So if you think of an example like a integer add pipe that takes two integers, sums them together, and returns the sum result of those two. Given any two integer input values, it'll always be the same output for that. Now, if you have some other pipe that is maybe doing some sort of random number generator, or maybe it's doing something based off of the system time clock, all of those types of things are obviously going to be non-deterministic results, and those are not going to be not pure pipes. But what happens, and this is very similar to binding to properties versus binding to functions that we talked about a minute ago. But if you tell Angular that all your pipes are pure, which you can do with this pure true attribute here, if you tell them that all are true, then what you're basically saying is that they're all deterministic. And Angular does not have to check to run your pipe again unless its inputs change. So this just basically makes your application more performant because now your pipes only run if the inputs change. They don't run all the time on every re-rendering cycle. All right, so I mentioned this earlier, but you can also use something called a web worker if you're doing some background tasks. A lot of web developers don't seem to be familiar with this, but actually all of the JavaScript that we write today typically runs on the UI thread of the browser. It's running on the same thread that all of the browser's UI stuff is happening on. And so if you're doing some sort of heavy processing, let's say you call a REST API and get a bunch of data, which is a non-blocking call. But once that data comes back, then you're going to loop over all that data and do some sort of heavy manipulation, I don't know, image processing or some sort of heavy manipulation that you're going to do in the JavaScript. Well, if you're going to do that, you're going to be doing some blocking on the UI thread. And it's really a lot better to spin that off into a background thread, which you can easily do with this concept of a web worker, which you can set up as easily as just creating a new worker and pointing it to some code that it's going to run, and then sending messages to that worker. So that's kind of how it works asynchronously, because you just post messages to it. Inside the worker, all you have to do is handle the on message, where it basically gets an event argument with some data. So you can send post message with some data in there as a parameter, and it'll come through in the e.data. You can use that data to do your processing, and then throw another event that could be caught by the calling code to handle that. And so now you've basically turned your the synchronous blocking heavy processing into something that is asynchronous in a background thread. So while the user is maybe clicking and scrolling and interacting with your application in general, this heavy processing can still be going on in the background, but it won't negatively impact their experience of your UI. So web workers are a specific kind of service worker, and service workers have some other benefits to them in general. There's other kinds of service workers that you can create. You can think of them as sort of being like middleware. If you're familiar with middleware in other technologies like ASP.NET Core, for example. They don't really have DOM access, so they can't manipulate things in the browser, but they can basically intercept things that are happening in the background. So they can run code in the background, as I mentioned with the web worker. They can intercept network traffic. They can cache results of network traffic. That could be assets in your application, like JavaScript files or images. That could be API responses that maybe you want to cache in your front-end application, and all of the code that's calling a certain API, you only want it to maybe actually hit that API once every 30 minutes. Maybe it's a high-cost call and you want the rest of it to be cached. And you can easily do that by just intercepting that network traffic in a service worker and either caching things or manipulating data as it comes in and out of your application. One of the things we often use this for to speed up our applications or make them more predictable at Trailhead is we'll actually use them to write our own custom caching logic. So I don't think there's a web developer in the world who hasn't run into a browser caching some file when they didn't want it to. And if you have your own custom solution to that, where the application is essentially downloading its own assets and checking the server to see if there's new updates, you could actually hit an API and see if that API responds with a new version number, and if it does, go back and request new files. There's really a lot of really cool stuff that you can do with these service workers' ability to intercept that network traffic. All right, so another issue that we often run into when we inherit an application from a client is CSS animations that are kind of heavy on the browser. And one of the ways that you could sort of evaluate what a good CSS animation versus a bad CSS animation might be is to look at whether the animation you're doing is going to affect the page layout, things like the width, the height, the padding, the margin, so on, versus whether it's going to affect a single element, like changing the opacity or doing a transform on an element. It's not unusual when you're doing something that will affect the page layout. Maybe you're animating a div to get smaller in width or something like that. That will have sort of domino effect, because the width of that div will probably affect the layout of the page in general. So a lot of other elements will then have to re-render multiple times as your element is changing through its animation. And that can actually cause your browser to have a lot of work to do. It can cause Angular to have to do some re-render cycles that you may not be aware of. And so if you're using CSS animation, one of the things we often recommend is to try and use it more for things that affect a single element. All right, so the next one, I think we've got maybe two left, I want to say. Yeah, two left in the Angular side, and then we'll switch over to .NET 5. So this one is creating something called sprites. If you're not familiar with a sprite basically takes a bunch of image files and combines them into a single image file. You might be asking yourself, why would you want to do that? And the reason is basically download overhead. So if you have, let's say your application has 50 icons, and you need to, when your application loads, maybe your CSS causes all of those to download. Most browsers are limited to how many open requests they can have simultaneously to the same server. So if your application, like the HTML, JavaScript, and CSS files all come from the same server that your image files come from, for example, while your application is downloading and then your JavaScript application is kicking off and starting, your browser may have actually queued a bunch of image requests that it can't get to because it's reached the maximum concurrent requests to your web server. And so now it's going to go get those a few at a time, whatever its particular limit. I think the last I remember, the limit was around 10 concurrent connections, but that may have changed recently. But about 10 concurrent connections, let's just say, for the sake of argument. And if you have 50, that's going to be kind of like 5 different blocks to go download them. Your user might actually encounter your application the first time as looking like it's having icons kind of load in as they become available all around your screen. And the solution to that is to basically combine those into a single file with just different XY offsets to use for different icons. And that can be a real pain to do manually, but there's some really great tools that'll help you do it automatically. So if you're using an Angular application, I would recommend these two NPM packages. For SVG files, which are the vector graphics for the web, you can use this SVG sprite package that will basically do this for you. You can, as part of your build process, you can point it to a location where it'll find a bunch of SVG files and it'll combine those for you and automatically update your CSS appropriately. And then if you're doing bitmap graphics like JPEGs and GIFs and PNGs, then you can use this node sprite generator. Is a pretty good NPM package for doing the same thing. All right, last one in the Angular section. This is third-party libraries. You'd be surprised how often this one comes up when we're looking at an application. You would think that when somebody didn't need a third-party library that it would kind of get removed, but it actually often happens that that's not the case. I think maybe multiple developers on a project, maybe not always communicating clearly or something like that, or maybe someone inherits someone else's application and they don't understand all of the third-party packages that are being used. But there is a kind of cool tool you can get from NPM that's called dep check. That's DEP check. That'll actually look through your package JSON file and see if there's any dependencies that you don't need. There's also some cool tools you can get as extensions in Chrome that'll do some similar stuff and tell you what you don't need anymore and what's taking the longest to download. Another thing we often run into is, of course, a lot of applications use Lodash, which is kind of like a list array and object manipulation library that's very powerful in JavaScript. And if you use Lodash, I highly recommend that you include Lodash from the Lodash-ES package instead of just Lodash. And the reason for that is that the Lodash-ES version of the NPM package wraps Lodash inside of ECMAScript module, which allows Angular and probably React as well to do something called tree shaking, which basically means that it can look throughout the code, through your code and the Lodash code, and look at what you're using and what you're not using. And if there's any code inside of Lodash that you're not actually using anywhere, it can remove that from the bundle before it's compiled. That, of course, makes your bundle size way, way smaller. And a lot of people don't realize this, but Lodash itself is not in an ECMAScript module, and so it can't be tree shaked. So that's something to keep in mind. Another one that a lot of people don't realize is that moment.js, which is a great date time library that's available in NPM that a lot of people use. It's a super powerful and very useful library. A lot of people don't realize that there's kind of a huge localization database built into it. That's about 300 kilobytes. And if you are not using any localization in your application, or maybe you're localized just within the US or something like that, you can actually remove the vast majority of that data, or you can download different versions of moment.js that only include different chunks of that data, and you can make the size of that library way smaller as a result. So some good opportunities there to save some space. All right, so we're through all of the Angular tips that I wanted to talk about. So let's talk about my performance tips for the backend or the middle tier in .NET 5. My first tip is that if you're still on .NET Framework, you're building Web API, maybe in ASP.NET or something like that, my first tip would be to strongly consider moving that to .NET Core. ASP.NET Core and .NET Core, ASP.NET and ASP.NET Core are not exactly the same, but they're extremely similar, and it's usually not super painful to go through the somewhat manual upgrade process for that, especially once you're familiar with the differences between the two. And you'll find that basically all of your code in your class libraries, basically all of your code in your controller methods, basically most of your code in your entity framework, if you're using that, a lot of that stuff is just going to come over and work the same way as it did before in .NET Framework. But you're going to get the full benefit of .NET Core by moving it and running it in ASP.NET Core on top of .NET Core instead. And you may be asking, okay, so what are those benefits? Well, .NET Core is this completely rewritten, faster, modern version of .NET. It's cross-platform, which is kind of cool because that means that now you can host your .NET application in Docker containers or on Linux servers in the cloud or in your data center, in addition to running it on Mac and running it, of course, in Windows like you always could before. But also, importantly, .NET Core is the future of .NET. For about the last 5 years, .NET Core has been the cool new flavor of .NET. But as of .NET 5, which launched just in November, as of that time frame, .NET Core is just called .NET now. So what we used to call .NET or .NET Framework or full framework, as some people call it, the one that we all know and love for the last 15, 20 years here that comes installed on Windows, that version of .NET, .NET Framework, is no longer really going to be updated with any new versions. It's going to get compatibility. It's going to get fixes, basically, security patches, all of that kind of stuff, and be supported for many years in that way. But all of the energy, all of the new development of features is moving to .NET Core or .NET 5 as it's known now. And really .NET Framework is now, kind of officially the legacy technology. So that's another reason why you might want to consider moving. Not only is it going to your application going to perform a lot better, but you're going to no longer be sort of built on top of a legacy technology. One of the things that we often have noticed is that the exact same code with really no optimizations, we can often get between 2 to 6 times the performance out of it that we had in ASP.NET when we move it to ASP.NET Core. It really depends on a lot of the other bottlenecks, of course, database access, and there's so many different things that code could be doing that could be a bottleneck to it. It's a little hard to give a universal performance improvement, but I'll just basically say it's always been very significant and totally worth the migration whenever we've been able to do that. The next tip I would give is if you're building an ASP.NET application is to use application insights. This is actually something you could use in mobile applications. You could use this on your Angular or React front-end applications, as well as your back-end applications. But I wanted to mention it in here. It's kind of a Microsoft technology. It's something that's available in Azure. Up to a certain number of requests a month, which I want to say is like 1 million or something like that. It's a pretty high number. It's totally free. Once you go above that, then you start paying, by the tens of thousands of log events, and it's still extremely reasonable. It's the sort of thing that becomes a rounding error in most software development teams' budgets. But it really allows you to do a lot more insight into what's going on in your application. The reason I put this into a performance talk is because one of the beautiful things that it can do is it can show you things like response times and failures and request rates and wait times and all of those types of things for different parts of your application. It can show you stack traces, and it can show you queries that are happening inside your application and you can actually see very detailed information about what's causing different parts of your application to be slow. We find this to be a really great way to be proactive about building your application. So instead of releasing it and then hoping that users will report, certain endpoints that are slow that they would like you to look into, instead of relying on that, you can actually go to a certain report in Application Insights, and you can sort your API endpoints by the slowest response time, and you can see, your 10 slowest API endpoints. You can actually go into those few slowest ones and see stack traces and see where all of the time is being spent inside of the application and target fixing those things before anyone even reports them to you. You can also get errors that are being logged and get full stack traces about those errors so that you know what was happening both in the front-end application and the back-end application, what the state of everything was. Makes it way easier to debug those things and way more proactive. So highly recommend checking that out. Another thing that we often use so take for example, if we did do that stack ranking of the slowest API endpoints in our application, and we were trying to speed some of those as low-hanging fruit, trying to speed some of those up. One of the tools that we find the most useful for that is something called Mini Profiler. You can add Mini Profiler from NuGet. It's this very simple and fast and useful tool that helps you to profile parts of your code. It was built by the Stack Overflow team. So if you're familiar with some of the other stuff that they've created over the years, like Dapper, for example, you may already have warm, fuzzy feelings for them and the stuff that they make. But Mini Profiler is great. And one of the best things I think about it is that unlike a lot of other profiler tools, installing it doesn't actually change anything about the performance of your application. You can install it in your application and it won't do anything. That might sound like a downside, but I think it's actually great because a lot of times you'll install a profiling tool and maybe you don't totally understand how to configure it correctly. Maybe it goes out with your production application and it's accidentally configured to still be on. Any profiling tool is obviously going to create some overhead and slow some things down. And if you're profiling everything in your application accidentally, that's slowing everything down. And so I find Mini Profiler to be quite useful in the sense that it requires you to basically turn it on a method by method or stack trace by stack trace case. So I think that's a really cool thing about it. Another cool thing about it is not only can it see a stack trace into your .NET code, but it can see into your SQL queries and see what's going on in things like Redis and HTTP requests if you're making HTTP requests to backend systems. And it can actually give you a lot of information. So if you look at this particular stack here, you can see that the SQL query is taking 42% of it. So if I was trying to fix this particular endpoint, I'd probably start with that SQL query because that's taking such a big chunk of the time. All right, the next thing that we see pretty commonly in .NET Core or just API layers in general is that the DTO objects that they return are often include way too much data. And the really easy solution to that is to create something called a DTO. Now, if you're not familiar with that acronym, it stands for Data Transfer Object. And what it really means is basically instead of having, let's say, your entities, which have a property for each column in your database, instead of always returning your entities over the wire to your front-end application, maybe you map those entities to a smaller object or a smaller list of objects with fewer columns, fewer properties on them, so that there's less data to go back and forth over the wire. So you're only sending the data that the front end actually needs for that particular endpoint. So that's called a data transfer object. It can be a real pain in the butt to manually map your code from your entity to a data transfer object. You've probably seen this code before where you basically say, you know, first name equals the first name from the entity, and last name on my DTO equals the last name from the entity, and company name equals the company name from the entity, and blah, 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 right? Like every single property having to be copied over line by line, one at a time. If you miss one, you're not going to discover it until it's a bug later or whatever. So there's this great tool called AutoMapper. You can get it in the NuGet repository. Just search for AutoMapper. It allows you to basically set up definitions of types and how they map to other types. It also has certain conventions that are built into it. So if you have two types that you want to map and they have properties that have the same name and type, they'll just automatically map. You don't have to do anything to set that relationship up. And then if there's any kind of custom mapping that you want to do, maybe you want to turn an enum into an integer to save it into the database or something like that, you can do all of that stuff as well. So it's a really useful tool. What's really cool about it is that it also works with Entity Framework iQueryables. So if you don't know what I mean by that is that you can do a query into your database, and instead of returning entities with every single column that's in your database, you can ask AutoMapper to map those into your DTO right there in the SQL query, and your SQL query will automatically only pull back over the wire from SQL the columns that you're actually going to map into your DTO. So that actually saves some time and processing power and network bandwidth right there in between your middle tier and your SQL server as well. Not to mention, obviously, when you send that over the wire as JSON. So pretty useful tool. Just as an example, you could look at this middle tier application here with its get widgets method. And if that goes to your database and gets an entire widget object or entity from your database with all of its columns, and then maps that into something smaller inside of get widgets and just sends the widget DTO with a smaller number of columns or properties in it over the wire, you're going to have a much more performant application. If every endpoint is doing this, there's a lot less network traffic for your application to process through. Okay, I mentioned this about AutoMapper already, so let's just look at a quick example of how easy it is to use AutoMapper. If you want to use AutoMapper, like I said, you bring it in from the NuGet package, and then you set up a global configuration using this mapper configuration. You can do this a lot of different ways, but here's one that's basically just using the automatic by convention configuration. So it's saying create a map between the widget and the widget DTO type. AutoMapper is going to look at those two types, look for any properties that have the same names and types, and automatically create a relationship with them to allow you to map from a widget to a widget DTO. Then I'm going to create something called a mapper object. Now I can access this mapper object anywhere in my code, and it's going to know how to map things globally around my application. All I have to do is basically say I want to map this my widget object to a widget DTO, and now I've got a DTO copy of that. In one line of code, it copied my first name property, my last name property, my company name, et cetera, all of those properties automatically, as long as I named them and typed them the same, are going to get copied from my widget to my widget DTO type. Pretty cool, time saving. All right, this is the halfway check. Just want to make sure that we don't forget about it. I see we're at, looks like maybe 30% right now. So thanks to those who've given some money already. For those that are still holding out to see if they get a useful tip, hopefully I've got something good for you in the next little bit here. And you can go to bit.ly/WI-water, WI-water, and maybe donate a little something. Remember, if you all hit $200 during my talk here, I'm going to match it. All right, so enough of that interruption. Let's get back to our performance tips. Another one that we get asked very frequently by clients is, should I use Entity Framework or not? If you've been following the Entity Framework team at all recently with the Entity Framework Core and the next version of that they're working on right now, you may have noticed that they're talking a lot about something called Dapper. Dapper is a micro ORM that allows you to do, essentially, you write the query, the SQL query yourself, and then Dapper will just run that query and fill objects with the data for you automatically, or lists of objects, or complicated trees of objects. It can do all of those types of things. And the beauty of something like Dapper is that it's really, close to the metal, as they say. It's really low layer. There's not a lot of interpretation or things going on between Dapper and the database. It's just basically executing SQL for you and filling objects up with the data that comes back. And the beauty of that is that it's hard to perform much better than when you strip things down to just their bare minimum like that. And so for years, Entity Framework has really struggled to be as performant as micro ORMs like Dapper. And I'm happy to say that the Entity Framework Core team now is paying a lot of attention to that. They're trying to get their performance down to be comparable to Dapper, and they're getting much closer to that in their defense. I will say, if you're using older versions of Entity Framework Core, certainly if you're using Entity Framework 6, it does not perform as well as Dapper, and probably never will until you upgrade to one of the more recent versions. I think the bigger problem in that, and I actually have a whole talk that I do about using creating a data access layer in .NET without using Entity Framework that performs better. And in that talk, I kind of talk about some more details about some of the things that Entity Framework does kind of by default, kind of not on purpose, to encourage bad architectures and bad habits for developers. But I would basically say, if you're not an Entity Framework expert, it's quite possible for you to make mistakes that cause your application to perform poorly. It's a lot harder to do that with a micro ORM. You can write a bad SQL statement, and that's about it. That's about the only way you could make it perform poorly. And obviously, if you have a DBA or a database developer or something that can look at those SQL statements for you and improve them, or maybe you know how to do database SQL optimization, then you can improve that performance. There's a lot of things I won't go into, but basically what I often tell clients is that if you feel like you are up to speed on Entity Framework and you really understand how it works, it can be a good performance choice, but just be aware that there are pitfalls to it, and that if you choose something else like Dapper, as an example, the chances of you making a mistake that causes bad performance in your application goes way down. Just real quick to show you kind of how something like Dapper would work. You create a SQL connection or some other kind of database connection object, and then right directly on that connection object, there's a bunch of extension methods, like this query first or default. You pass it a generic type that you want the results to be, and then you give it a SQL query. In this case, I've just got it defined like a hard-coded SQL string, but you can see it is parameterized with the @ID and then passing in the parameter ID equals 123. So if you're doing parameterization here, you can make sure that SQL injection isn't possible in your application. And this query is basically going to go run this select star from dogs where ID equals 123, and it's going to return the top row, and it's going to deserialize that into a dog object and give you that into your dog variable here. Similarly, you can execute insert, delete, and update statements. Here's an example where you're inserting a couple columns into a table and then passing those columns. You can pass them here like I am as a dynamic object, or it could be a strongly typed object, as long as the property names match the names of the properties here in the SQL statement. Everything will work automatically. So kind of cool, real easy to write good SQL that way. If you do decide to use Entity Framework in your application, the few things I would kind of point you to try and avoid some of the most common pitfalls are to try and make sure you and everyone on the team knows the difference between the iQueryable interface and the iEnumerable interface. Just the high level of what that is. They all kind of look the same, but anytime you see in your code a .toList, that is essentially taking the query, executing it, and turning the result into an in-memory in your .NET code iEnumerable or a list in memory. And then any manipulations you do, wheres or selects or joins or groupings or anything you do after that point, it's going to be happening in memory inside your .NET application. If those are queries, groupings, and wheres and selects and stuff like that, those are probably things that actually SQL is a lot better and faster at, set logic. And so it's better to be doing that while it's still an iQueryable before you've actually made that into an iEnumerable. So just be aware of that and keep that in mind. Another thing, I mentioned it earlier, but AutoMapper has this great project to extension method that you can use on your queries. You can basically take any entity query and project it to a type. That's essentially going to keep you from pulling back a bunch of columns from a bunch of tables that you don't really need when you're just trying to get some set of columns or properties to populate a DTO that you're going to actually send back to the front end of the application. This project to is a lifesaver for that. And then if you're using Entity Framework 6, so that would be for .NET Framework, .NET Full Framework, make sure that you disable lazy loading in web applications. There's really no reason for lazy loading in a typical web application. And I'm happy to say that in EF Core, that is the default setting. It's disabled by default. And then the last one I would point out is that the as no tracking extension method on your queries is super useful and very valuable to do. So a lot of people don't realize that if you say as no tracking on a query, that change tracking will be in effect. So if you're doing a query of the database and you're pulling back 1,000 widgets from your widget table, and then you're just serializing those widgets and sending them off as JSON over the wire, that's a lot of overhead to also be tracked to set up the change tracking for those 1,000 widgets when all you're going to do is just serialize them and not make any changes to them at all. And so in that case, it's a no-brainer. You want that query to not do change tracking. And that will disable all of that overhead that Entity Framework adds and make a pretty significant, like 2x, 3x difference in the performance of your queries just by getting rid of change tracking. All right, so the next tip is when you're thinking about your SQL queries. So even if you're doing Dapper, of course, you can write bad SQL queries that can perform poorly. One of the big things that we see is pulling back too many columns. So select star from tables, or select every column by name from tables when I only need 5 of them. That can be a real killer for performance. Keep in mind the database has to do more work, and the network has to send more data back and forth, even though you're just going to throw it away once it gets to your middle tier. So keep that in mind. Try and just pull back what you need. When you're doing a bunch of deletion and updates, it can be helpful to batch those so that you're not basically creating a bunch of dirty records that are blocking other reads to your database. So if you're going to do 1 million deletions, try and batch them up. So you do 1,000 and then commit that change, and then do the next 1,000 and commit that change, so that you're not blocking 1 million different records that the database can't read while you're waiting. Try not to double dip. So when you're joining to things, try to just join to a single table once. You can often pre-stage data. This is a great tip that some DBAs have taught me over the years, that if you're going back for the same data that doesn't change very often, you can run a query on a schedule and just stage that data into a table and use that table in your queries. And now you've got the advantage of being able to join to that table and having indexes. Or you can also sometimes find that if you have a query that keeps going back to the same underlying query, you could do that underlying query once and put it into a temp table, and then use that temp table as part of the underlying query for the next like outer query. And oftentimes you'll find that that'll perform better in SQL. Negative searches can be a real interesting performance problem. A lot of people don't realize this, but the way indexes work, if you say, give me all of the widgets where the inventory is greater than 1, if that column is indexed, it can be very quick to find that. But if you say, give me all the widgets where where the quantity on hand is not equal to 1, now it basically has to scan through that whole table. There's no shortcut to doing that type of a query. So just keep that in mind. If there's a way you can keep the filter positive, there's a better opportunity to use the indexes in the database. And then, of course, you want to make sure that anything you're joining on or selecting on is indexed in your database. All right, so .NET Core adds this new, this is as of, I think, ASP.NET Core 2.0, adds this new serialization library. It's called system.text.json, which isn't the most friendly name or doesn't exactly roll off the tongue, but probably most of us are familiar with JSON.NET, which has been the JSON serialization library for the last several years in .NET, the kind of go-to serialization library. And system.text.json was basically built from scratch to do JSON serialization and deserialization much faster than JSON.NET does, and to take advantage of a lot of the low-level performance and memory improvement stuff that's built into .NET Core that JSON.NET can't take advantage of because it's cross-platform for .NET Framework and .NET Core. So a couple of tidbits about this. First of all, you will definitely see serialization speed improvements and memory allocation improvements if you switch to system.text.json. You should be aware, though, that system.text.json has some different default settings than JSON.NET does. So if you are doing a greenfield project, that might not be a big issue to you. You can handle any of those defaults a little, you can handle them as you go. If you're migrating an existing application, that can be a little messier because now maybe some of your properties don't serialize with quite the same name or work in exactly the same way as they did before. So just keep that in mind. There is some pretty good documentation on the docs.microsoft.com that tells you what those differences are. So you can check that out. Another problem we sometimes see is that people are so keen on logging what's going on in the application as a way to try and figure out performance problems that they actually create performance problems. So just be aware that in .NET there can be a ton of events that get fired, especially if you're at the trace or information level of logging. So when you're logging in production, you should make sure that you're logging really only warning or critical level stuff. And in development, you could do a little bit more, but just keep in mind that if you go very far past warning, you're going to be getting an absolute ton of stuff, and you're probably going to be impacting the performance of your application. Another thing that we often end up adding for clients to their existing applications is some sort of a memory cache. So a lot of times you'll find that there's certain sets of data that you're getting over and over, and that data doesn't really change that often, and it's used frequently throughout the application. So I'm thinking of like maybe the states, the US states in like a mailing address dropdown that load just over and over all throughout your application. Or maybe it's like profile pictures for your users, or some other lookup options that don't change very frequently. Maybe your like product types don't change very often. Those types of things. Those types of things are really great matches for a memory cache. You can use something like we've used both Ncache and Redis. So Redis runs really best on Linux, and Ncache runs in Linux or in Windows. And so Ncache is actually built with .NET. So if you're kind of keen on using .NET stuff and keen on Windows, that can be a pretty good option. Redis is definitely the industry leader, or the most common one that people use for this. And then the rest of your application data, you can just let your underlying data store, probably a database, do all of the unique queries, things that are different every time you query it, or any of the writes to your database are going to happen to that database. And you've offloaded some of the other stuff that's just common, infrequently changing data to your memory cache. So just as an example of what that might look like, imagine you have this API, it's got 4 endpoints. One of them gets the countries, all the countries in the world. One of them gets a profile picture for the user. One of them gets, one of them creates a new order, and one of them gets all of the orders for a particular customer. Those are all kind of querying that information out of your database. Now imagine that in your application, the profile pictures are happening 10,000 times a minute, and the countries dropdown is needing to load about 100 times a minute. Well, you can imagine a scenario where that's enough to keep your database busy, just loading profile pictures and just loading countries, even though those really change pretty infrequently. And now maybe the database isn't going to be very responsive, or maybe it's going to time out on things when you're trying to create an order or get all of a customer's orders. So the way you would set this up, if you use Redis, for example, you would put Redis kind of between those endpoints in the database. They would query Redis first, and if Redis didn't have that data, it would go to the database and fill it into the Redis cache. And then maybe every hour you tell it to go ahead and go back and check those things again. But all of those other 100 times a minute or 10,000 times a minute, it's just going to be reading out of memory from Redis and not actually hitting your database at all. Now that frees your database up to do the things that it's really good at, getting these unique queries or creating new data, new transactional data. All right, next one, response compression. I see a lot of ASP.NET Core applications where this hasn't been turned on. So when you're creating data and sending it, whether it's JSON data or HTML data from an MVC application, you can actually gzip that data or Brotli compress, which is a different compression algorithm. And those are components that are built right in by Microsoft into ASP.NET Core. And so kind of what you can think about here is that you're kind of trading off a little bit more server-side processing for smaller packages going over the internet. And when I say smaller, I mean a lot smaller. So gzip, by default, depending on the type of data that you're compressing, can often compress JSON data about 95%. So basically your transit times over the network are going to be significantly faster. What's interesting is that the newer Brotli algorithm is able to work a little bit better. It does a little bit better compression, about 15% on average better than gzip does. But even better than that, it does it with about 20% less processing power on the server side. So it's really a best of both worlds to use the Brotli algorithm, because you're still going to get high 90s compression rates, and you're going to be getting it for about a 20% reduction in processing to do that compression on the server. All right, next one. One quick example of what that looks like. It's super, super easy to add response compression to your ASP.NET Core application. You basically, so the startup class for ASP.NET Core has these two methods built into it: configure services and configure. Configure is where you configure your middleware. So that's kind of your request and response pipeline stack of middleware that's actually processing requests. And then configure services is where you do all your dependency injection setup. So basically 2 lines of code. Once you've added the NuGet package, you say services.add response compression. That's going to set up all of the dependency injection services for compression. And then in your configure, you set up the response compression middleware, which, because it's doing the actual compression of the responses, you want to make sure it's at the top of your stack. So if you have MVC in there, you're going to want that down the stack below that, so that the response, so the requests come in down the stack and the responses go back out up the stack. So you want those responses coming back out up the stack to hit your response compression last on the way out. So that's, you want to make sure at the top. I know a lot of people find the async await stuff in C# a little confusing. And maybe because of that, I see a lot of times where API methods are not using async methods, even though they very well could. And that's especially true if you're doing like database queries, which are, become blocking essentially if you're doing it synchronously. And all you really do is change your response type to a task of the response type that you want, and then mark it with async. And then all your other async code within that method, within that controller method, can be async if you want at that point. The benefit of that, I have this little diagram to show. Imagine you've got this thread pool, right, that can handle so many requests at a time. Now let's say you've got, just for the sake of argument, let's say you've got 2 of them, just to make the diagram really easy. Now imagine that those threads are handling 2 requests that are coming in around the same time and passing those off to controller methods that are synchronous. Those controller methods are synchronously making a call to go get some database data. It takes the database a few milliseconds, maybe 20, 30, maybe even a whole second to run that database query and actually return those results. During that time, that synchronous code is blocked, which means those threads are blocked, which means those requests are kind of spinning and waiting. But those threads in the thread pool can't do anything else but wait at that point because it's synchronous. Now, when the third request comes in, it just has to wait, and your application now feels slow to that user because they're just waiting for a thread to be available in your thread pool. Now, just switch those methods to async methods, and now when they're blocked waiting for that SQL to come back with the result, if a third request comes in, that first thread could say, oh, I'm just waiting anyway asynchronously for something to happen. I'll go ahead and switch over here and start handling this third request. It can start handling that third request right away. Maybe assume that's a faster processing, and then thread 1 can swap back out and go back to request 1 and finish handling that request once that SQL query gets unblocked. So I think you can see how your application can actually scale quite a bit better if you use those asynchronous endpoints instead of synchronous. An issue I see with a lot of applications is kind of using exceptions as a way to control the flow of the application, as opposed to maybe return types or status values coming back in objects or things like that. When you use exceptions, a lot of developers don't realize this, but there's quite a bit of overhead when you compare it to the normal flow of calling methods and returning values back up the stack and all that kind of stuff that we consider sort of the normal flow of an application. When you throw an exception and it causes your application to bubble that exception up to somewhere where it's handled, it can actually create hundreds of times of overhead compared to the performance of that same call stack without the exception. So make sure when you're using exceptions, you're only really using them for exceptional situations, that you're never using those for a situation where you're just trying to control the flow of the logic. It uses a lot of memory, it slows things down, and it's going to make your application work a lot more poorly. Last tip on this section: when you're creating an API or a web application, it can be very, very helpful to load test that application. There's this great tool called JMeter by Apache, and it allows you to do things like recording sessions, or you can write your own code in JavaScript that grabs values out of responses from certain API calls, like say a login API could then return the value and put the token into some variable that you use on future calls. So you can automate a lot of stuff. You can also record a certain set of web calls that you might do manually, and then you can rerun those calls back. You can program them, like I said, customize them, rerun those HTTP calls back, and essentially simulate all kinds of users using your application at once, and start to get an idea of where the bottlenecks are going to be when your application is getting more heavily used. Of course, there's ways to do this that are not very realistic, that will be less helpful, but if you're careful about how you design your tests, and make sure that you're not hitting the same records in your data over and over, and using different users, and varying the patterns with which you're calling those endpoints and so on. If you do all of that kind of stuff, you can get some very realistic and very helpful information about where your application is going to do well and where it's not going to do so well when it's under load. So we often use this towards the end of many new projects to test, to make sure we know where the weak points are and we can shore things up there a little bit. All right, so we just went through 26 tips on Angular performance and .NET 5 performance tips. Out of those 26, I hope at least a few of them were useful to you or new to you. I haven't seen any questions come through on the chat, so that's okay, because I've got a little time here for Q&A. But I do want to remind you, we're still at, it looks like 30% on the charity water thing. So if you want to go to this bit.ly link, there's, let's see, what are we at here? The total is 80 bucks. So we've got about 120. If people give 120, then I will match that. And I'll go ahead and give you to the end of our time together here. So go ahead and scramble and go to that bit.ly link if you want to do that, if you're interested in doing that tonight. Thanks to those that already did. And that brings us to the Q&A time. Feel free to unmute if you want to ask questions, or you can type things into the chat, whatever's easier.